cannot pass through that solid stationary phase. So that's why GSC or gas solid chromatography is obsolete in nature. Very rarely it may be available only for research purposes. Otherwise, it is not available in the market. Another is the GLC or gas liquid chromatography. That means stationary phase is liquid, mobile phase is gas. So very easily that gas can be passed through the liquid. There are some techniques. So that's why the majorly gas chromatography means gas liquid chromatography, GLC. So what are the component of the GC? In the third slide, in the block diagram you can find that is the carrier gas, then the flow regulator and flow measurement also available, then sample injector, then column, detector and recorder. These are the 5 major component of gas chromatography. We will be discussing one by one very quickly. Just I will discussing. Okay. So first is the carrier gas. See, carrier gas we are discussing in instrument, though it is not the part of the instrument, but still it is having important role in gas chromatography. So what is carrier gas? First of carrier gas is the mobile phase. In gas chromatography, carrier gas are the mobile phase. So generally certain inert gases are used as a carrier gas or mobile phase. What are that type of gases we can use? Nitrogen, hydrogen, oxygen or zero air, helium, argon, etc. So these are the inert gases. Why we should use inert gases? Because they should not react with the sample. Otherwise, if they are reacting with the sample, so sample will be converted into other compound. So we cannot analyze the sample ultimately. So that's why inert gases should be used as a carrier gas or as a mobile phase, so that their role will be to carry the sample only. They will be carrying the sample without any chemical interaction. So all these type of gases are commonly used, but very commonly used gases are like argon, helium, etc. So they can be used alone or sometimes they are used in a mixed ratio, different ratio they can be used. Next part is the flow regulator and flow meter. Flow regulator and flow meter, there are 2 type of components are there, rotameter and soap bubble meter. In the rotameter, one small, what is the role? First of all, this role of this component or this part is to regulate the flow and to measure the flow. So both the things they can perform, they can regulate as well as the measure the flow rate of the carrier gas. 2 type of instruments or equipment is available. Rotameter, where one very light plastic float is used to see the measurement of the rate of the gas flow. Whereas in soap bubble meter instead of this light plastic type or very lightweight material, instead of that, just bubbles are used. Bubbles which is coming from soap solution, they are used to measure the flow rate. So that's why name is soap bubble meter. So these 2 components again, they are not the part of the main instrument. They are not the part of the gas chromatography. They are kept aside the instrument. Separately, they are used and they are connected with the instrument. So this is a auxiliary or extra component, but very important to operate the instrument. Next one is the sample injector. In sample injector, already I have discussed this system of injection in HPLC. You see, you can see the figure. In sample injector, we are generally using the rheodine or loop injector. The same type of injector are used in HPLC. So I'm not going in details. The only thing you remember, there will be two things. One is the two position. One is the load position. Second one is the inject position. In the figure, you can see loops are changed. Connection of loops between load position and inject position is different. By the change of the loop, sample is injected or introduced in the carrier gas. So here, you remember, once again I am reminding you, in the load position, sample is loaded on the injector part, not introduced in the mobile phase. It is not the injection directly. So we are injecting by two phases. First, sample is loaded. That is loaded by a normal syringe also, or somewhat specialized syringe are available. So by a syringe, samples are introduced in the injector port. Then the knob will be there, injector part knob will be there. Will be changed the position of the knob so that load position will be changed to inject position. Loops will be changed, and by this way, actually sample will be introduced in the mobile phase or the carrier gas. So that time, that sample will be carried out. After that, sample will be carried out by the mobile phase. So that is the actual injection process. So by these two steps, sample is introduced or injected in the system, in the mobile phase. So definitely very important role of this part, sample injector. In this part only sample is injected. Next part is the column. Column is very important. As you know, this is the theoretical, this is the, sorry, stationary phase. That is the stationary phase in any type of chromatography. In HPLC also you have studied column. In GC also there are different columns are used. So column means stationary phase where the samples will be separated by the interaction with the mobile phase. So here definitely columns are slight different from the HPLC column. Here mainly we are using two type of column, packed column and open tubular column. Packed column means that is packed from the inside. Inside column, inside part of the column is packed by certain substances or certain materials. So the packed column is not so convenient nowadays because carrier gas cannot flow properly. Actually, packed columns are used in case of gas solid chromatography. As you know, I told in the beginning, gas solid chromatography is obsolete nowadays. So that's why packed columns are also not so used. Whereas, like another type of column, open tubular. Open tubular means it's a hollow tube. It's a tube, any type of tube you can imagine. Actually, the tube means it is a hollow. You can imagine the water pipe. You can imagine the electric pipe. So the pipe means it is hollow inside. ভেতরটা খালি থাকে পুরো। So the is coated on the inner wall of the column in by special technique. So ultimately the inner of the column is coated with liquid stationary phase, and a large hollow portion will be there where the carrier gas can move very freely. So the interaction that's why these open tubular columns are very popular nowadays. This open tubular column, again, two types are in use. One is the wall coated open tubular WCOT, and another is the support coated open tubular SCOT. What is the wall coated? Wall coated means when the inner wall is directly coated by the liquid mobile phase, sorry, liquid stationary phase, that is known as wall coated open tubular. Whereas support coated open tubular means that inner wall is coated with liquid stationary phase over the solid support substance. There are maybe some certain type of solid support material, solid porous material, or solid adsorbent may be used as a stationary phase and coated with some specialized liquid. So now this type of coating of liquid inside the wall of the column is a very specialized technique. So by this we can get a very thin film of liquid, 0.5 micron, like the thickness of the liquid will be there. So ultimately 99.99% of the inner portion of the column will be open. So gas can move very easily. So sample can be also carried by the mobile gas, and the interaction between the mobile gas and the sample with the system will move. So the separation will take place very easily. So this is the types of the column, and one very important characteristics of gas chromatography columns are it may be up to 100 meter. You can imagine the GC column may be 100 meter in length. So for accommodate this long this column in a very small place, they are kept in a coiling, or in a one place they are packed together or very closely. So they are kept in a coil. GC columns are available packed in a coil, যেটাকে বলা হয় একসঙ্গে গুটিয়ে রাখার মতো, so that a long column can be accommodated in a very small place. And due to the long distance or the length, very high length of the column, separation is also very accurate or minute or proper. So separation, so the extent of separation in gas chromatography is very good. That's why they are also much more sensitive. And finally, the detectors, they are the another last but not the least and most important part of the gas chromatography is the detector. The detectors are the component where the sample is detected. After separation takes place, what are the samples are separated or collected that can be detected or identified by detector. So what are the detectors we can use in gas chromatography? Number one is the differential thermal conductivity detector, DTCD. This differential thermal conductivity detector, from the name you can assume, is that the separation of the identification of the peaks, we get the peak from the sample by which we can identify, yes, some component is separated or sample or certain component is present. By the peak we can identify. So differential by the this type of detectors works on the principle of differential thermal conductivity. So if the thermal conductivity of the component is changed, and the inside, actually this type of detector use a Wheatstone bridge. A Wheatstone bridge is connected with an electrical signal. I am not going much more details because you can very easily understand if you read this. So in a Wheatstone bridge, they are the part of this Wheatstone bridge. So when, very simply I am telling you how it works, there will be two portions in the picture of this detector. You can see through one portion only the carrier gas will be flowing. Another portion will be there where the carrier gas along with the sample will be flowing. So that is a comparable detector. So when initially sample is not separated, in both the two portion or both the two area, only carrier gas will be passing on. So the thermal conductivity of this both the gases, both the area will be same. But when the sample will be passing with the carrier gas, so the component will be changed. Thermal conductivity of that gas carrier gas plus sample will be changed. So there will be change in the resistance. In the Wheatstone bridge, there will be a resistance. So by the change of the resistance, there will be a current flow in the galvanometer. So by that we can measure how much amount of the sample is passing through the carrier gas. So by the change of the thermal conductivity, actually, the remaining other activities that takes place. So that's why the name of the detector is thermal conductivity detector. Due to the change of the thermal conductivity, the resistance of that carrier gas change, and by that we can measure the amount of sample is collected. Next one is the flame ionization detector, or FID. In flame ionization detector, this is one of the very sensitive detector, most sensitive detector. Only thing is that here sample is burned. Sample is destroyed in very high temperature, 400 or 500 degrees centigrade. Sample is burned. So when the sample is burned, the fire is coming from a nozzle or the portion where the metal portion will be there, and that metal will act as a electrode, and when the sample will be burned on that flame, on high temperature flame, sample will be